Alright, I recently made a video where I was controlling a microcontroller from PowerShell on a laptop. And in that video I was talking about why I never use a Raspberry Pi, because I just use my regular system and just come to an Arduino from laptop. I did a quick example and I thought, well, when I put it together I was thinking, well, people familiar with this stuff can probably figure out where to take those basic concepts. And I thought, well, why don't I go ahead and do a more thorough example for people that aren't quite familiar with this and well enough to do it and get started doing that. So we'll be controlling a microcontroller from the laptop and basically use these as GPIO pins for the laptop. Go directly into the system, which is running Windows 10. So I'll be doing it on PowerShell, but most any programming language can communicate with the serial port. So I'll be using Arduino Nano for this today. A knockoff of Arduino Nano. I recently ordered a dozen of these straight from a factory in China. Same thing with knockoff Unos. Getting a bunch of them right from China. They're really cheap. Often it's not even the most expensive piece in the circuit that way. But a Nano is essentially the same thing as an Uno. All the same pinouts. 0 and 1, I don't usually count those pins, and going to be communicating through the serial port, so the internal usage of those pins is going to be occupied. So I'm not using those at all. But then 11 digital in-out pins, and then the same ones that would have PWM on an Uno have the PWM here. So like I said, it's the same thing as an Uno, just a smaller package so that it plugs right in a breadboard. 7 analog inputs, the 3 volts, 5 volts, pushing out the supply voltage if you're hooked to a battery or something. All the same features we'd find on an Uno, it just fits in a breadboard. So I'll be using that. My normal setup for this is kind of like this. The way breadboards tie together, I found it's very useful to go ahead and put 2 of them together, have plenty of room to work. And then obviously the 5 volt and ground rail up here. And then with those middle ones connected like that, it gives 4 nice rails in the middle. I found that's really useful to go ahead and sort of semi-permanently connect the SPI communication. So I have the MOSI and MISO and clock going down a rail. Then another rail open, which pretty much always ends up being an extra ground rail. And a similar thing down here with just an I2C rail. And for my semi-permanent setup, you can see I left the pull-up resistors for the I2C rail with really long leads. That way they're kind of in the way. And that bumping them reminds me that if we're connecting multiple devices on I2C, we really have to watch the current. So those usually need adjusted. But otherwise, it's a nice convenient setup. We won't be using all that today. We're just going to be using getting some basic digital and analog reads and digital and analog writes, which analog writes is really PWM, pulse width modulation. So we'll just set up a little bit of that to do and then control it from PowerShell rather than the regular Arduino code. And that way this stuff feeds right into the Windows system on the laptop to control things. And the devices we put here can control stuff on the laptop. So let's get started coding this and then we'll come back over and hook up a circuit. Okay, so I started up a new Arduino sketch here and we can go ahead and get the code set up for the Arduino so that we can just send commands from PowerShell to control it. So obviously that's all going to be done from the serial port. So I like to just use the string. Oops, I have to spell string correctly, I'll call it PC command. So the command coming from the PC. And by default, it's just going to be a blank line. In the setup, well, all we're doing is sending instructions from sending instructions down the serial line. So all we need in the setup is the serial port. Then we can choose a rate 115/200 because we're going from a Windows PC to a Arduino, so we've got plenty of speed. But I think for this example, I'll just use the basic 9600, the kind of standard starting point. But whatever speed we want the baud rate to transfer those at, that's all we need to do in the setup. Then in the loop, what we're going to do is each pass through the loop, we'll just check and see if serial.available greater than 0. So we'll just check and see if there's anything coming down the serial port. And I'm going to label this one in serial available. And go ahead and label that closing curly brace because there's going to be quite a few here, so definitely want to keep track of where everything needs to go. And if there is something available on the serial port, well, we just need to plug it into this PC command string. So PC command equals, and I like to use this one, serial.read string until, and then we're going to read until we hit a new line character. So basically, whatever's on the serial port, read it until the new line character. And then we can just set up an if-else block. I'll come back and fill this in a moment. Else serial.print line unrecognized command. I can't seem to spell this morning. So if we don't know, we'll check all the commands we know, and if it's not one of those, we'll just go back unrecognized command. Some super basic error handling. But what if it is one that we recognize? If it is, then we want to do our basic things. So first off, I don't like working in the middle of the screen, so I'm going to add some white space here. Sorry, I don't like working at the bottom of a window, so just some white space for scrolling. That way I can work in the middle of the screen, which probably might as well be big here. So that's just so we don't have to work at the very bottom of the window here. But what do we need to do? We're just doing basic features this morning, so we'll need a digital write, then a digital read function, an analog write function, and an analog read function. And there's not a whole lot to do on these, so I'll start with the digital write function. So if we're just writing to a pin, we don't need to return anything. So void, I'll call it write. And obviously if we're writing to a pin, we need the pin, and then we need the level. Is it going to be high or low? And that's pretty much all we need. We'll set the pin mode. We're writing to it, so obviously that pin is going to be set to an output. And then digital write. Pin, whatever level we pass in. Oops. To whatever level we pass in. So that's all we need to do for this function. And then we'll just call it. And the others are going to be very similar, so I'm just going to copy and paste those. Control copy, Control C, paste, paste, paste. So I'll give it the 4. So the second one will be a D read. The pin we're going to read, well, if we're reading, all we need to do is know what pin we're reading. Our pin mode will be an input. Instead of digital write, we're going to digital read the pin, and, well, we don't need a second argument to read a pin. But we probably want to return that so that we can do something with it. So let's return that, and digital read is going to return an integer. Hope that wasn't too confusing. This is the way I usually write code. And when I'm showing people how to, teaching people how to code, I'll usually express that as a big deal, so I might as well do it here. The computer needs it to be in a certain order at the end, but that order probably doesn't match the way we think. So when I'm writing the code, I jump back and forth and put it together in the order my mind thinks about it, and then just jump back and forth so that for the final, when it's finalized, it's in the order the computer needs it. I find that much more productive. So what's next? The analog write. A write, again, what pin are we writing to, and the level. So obviously the digital write, that's going to be a 0 or a 1. And the analog write, that's pulse width modulation, so that's some integer between 0 and 255. Pin mode is going to be an output, and we're going to analog write that pin to whatever level we pass in, and we don't need to return anything. And finally, the analog read, I'll just call it a read. What pin are we reading? And we don't need any other information if we're just reading the pin. We just need to know what pin we're reading. It's going to be an input. Set the pin mode on that pin to input. And if we're reading, we just need to know what pin we're reading. Analog read that pin, and we probably want to return that, which that will be an integer. Alright, so I can get rid of my pseudocode here. And that's the functions that we're going to go over in this video. This little quick instruction, just basic GPIO pins and controlled from PowerShell, which means we'll be coming down the serial port. So next we'll set up some sort of communication protocol so that we know what to do when a certain instruction comes down the serial port. So now we're ready to call these functions and see if they work. So we'll come up here to this if statement. Here in our loop, we check and see if there's something coming down the serial port. If there is, we put it into this string called PC command. So then we can just check the PC command and see if that calls, if that's calling any of the functions we know about. So PC command, well, we're going to compare equals, but let me put a little comment here. I'm going to send this from PowerShell, so I'll kind of follow the format of PowerShell and space delimit things. So when I call this, I'm going to set it something like the name of the function, a space, and then the arguments being passed in. So to write a pin 3 high, it will look something like this. dwrite space 3 space high. So that'll be the string we need to check. And then it's coming from a PC, so it's going to end in /n. Carriage return new line. So that's why I do read until new line. But basically, that's the instruction we need to pass through. Or parse through. The instruction we need to parse through to figure out if we have something. So we need some substrings from that. So PC command substring, and I like to do this in strings. Could do it in just come up with some numerical code. I like to do it in strings because I find that a lot easier to work with and remember. you set up this protocol, and then instead of using somebody else's protocol where you have to look things up, if you just do your own, then the command is what you would call it instead of having to remember what somebody else called it. So that's definitely what I would recommend. Just come up with your own set of instructions to pass back and forth. And that makes it a whole lot easier to remember because, well, you don't really have to remember it. The instructions are all what you would call them. So we need a substring. So that's going to start at the beginning and go 1, 0, 1, 2, 3, 4, 5. So we want to go the first 6 characters, which is a computer, so we ask for the beginning, and we want 5 characters, so we need to count to the end of it. So if we put 5, that would be the beginning of the byte where this letter E is stored. So we want to go to the next one. We want to go to the beginning of the 6th character, the beginning of that space. So ask for the beginning, count from the end. Sort of a semi-standard across computers or computer programming languages. So if the first 5 letters of this string are equal to D right, well, then that's how we know we have this function call. So if we have that, well, then we need to parse out the sections of it. So I'm going to set up 3 strings for each section. One for the function, that'll equal something, string the pin, string the level we want it to be at. And these are, again, substrings of this thing, PC command. So, well, we already have the D right part, right? That's the first 5 characters here. So that's the function we want. And then the pin, PC command substring, we're going to get a substring from that. And the substring we want, well, it's going to start after the first space. That's probably the easiest way to find it. So we're going to start at PC command index of a space plus 1, because we want one thing after, we want the character after the space, not the space. And then, well, for this one, it's just 1 digit, so we could do 1 digit, but there's also the analog pin. The analog pins, we can digital write those. Those would be A0, A1, A2, so those are going to have 2 characters. And same thing with pins 10 through 13. It's going to be 2 characters. So the best stopping point is probably, I'm going to space delimit the instructions, so when we get to the next space, which will be the last one in that instruction, that's when we know we've hit the end of the pin number. PC command dot substring, and this one we're just going to go substring. Oh, no. I already did the substring part, sorry. So we're taking a substring and we're going from 1 character after the first space, and then we're going to go to the last index of a space. So we're going to go from 1 character after the first space and then stop whenever we get to a space again. And that'll grab whatever pin number we want. Then the level is similar, but we can just go to the last space, and whatever shows up after that will be ignored. We're going to have the /r/n on there. So we're going to go from the last space to the end, and then when we cast that to an integer, it'll just cut that off. It'll cut off the line breaks, or carriage return and line breaks, since it's coming from Windows computer. So PC command substring, and we just want to go from PC command index of, oops, not index of, last index of. So the last, we're going to go from the last space to the end. And that'll give us the 3 parts to it. And then we can just call that function. Once we have those parts, we're going to call dWrite with pen, which right now is a string, so we need to cast that as an integer. So pen.toInt. And then the level, same thing on the level. Level.toInt. So, probably ready to test this. May not have hit save yet, so I should save this. Libraries, well, I'll just put it on the flash drive with the little segments of videos that I'm shooting. That'll work. I'm not going to save this anyway. So, that should be everything we need. And that gets us to a point we can run a test. So this is one thing you always want to test every chance you get. As soon as you get to a point that you can run a test, go ahead and test that feature. That way you aren't overwhelmed with things if something doesn't work. And might as well check for typos. So if we hit Control R to compile it, because typos happen. If you're new to programming, oh, well, no typos this time. That's unusual. The sentence I was getting ready to say might have been better if there was a typo. If you're new to programming, don't worry about that. Typos happen. So my first exposure to programming would have been summer of 1988. Administrators wanted to make summer school interesting, so they were finding different things to catch people's interest, and I was in between 5th and 6th grade at the time, and the music teacher's husband was a programmer. So to make it interesting, he came in and showed us some stuff which was in some variant of BASIC. And I've thought back about it a few times. I don't think he ever told us what language we were working in. I know now it was a variant of BASIC, using Apple II machines the computer had around. And then at that time I had a DOS machine at home that I was working with. So that was summer of 1988. So my first lessons in programming basically were 32 years ago, and typos still happen all the time. So if you're new to programming, don't worry about typos. Just, they happen, fix them, and move on. And the main point I was making there is you want to run a test and check things every chance you get. So now we can go ahead and run test and see if we can call this command from the serial port. Okay, so back over to the little setup so we can run a test on that first function before writing, well, really copying and pasting that. So first off, the astute among you may have noticed when I shot that opening scene, one of the power lines, the power line for my I2C communication rail, it wasn't in there. So you may have noticed that I've replaced that. So we need to hook up something to test that with. So what I have for a quick test is when I begin to transition from high quality Arduino boards into disposable Chinese knockoff boards, I put together this little test setup. Normally I did it in C++, so the Arduino code is actually like the setup is a .begin, and then the loop just says run test, but a button, a potentiometer, and a light, enough to test the inputs and outputs. Whoops. Something made contact there that shouldn't have. A useful little thing, so it doesn't hurt to have something like that around for quick checks and things. I'm just going to hook up the light bulb here. So run the 5 volts, which I don't think I need, and ground. Put those on the rail, and then the light bulb. I'll just pick a random pin, D5. That'll work. So the light bulb on my little benchmark circuit connected to D5, which should be enough to test this. So we can see the light's off. So back over here, sorry about this scene of computer screen with phone video. So like always, first thing we want to make sure we have the right board set up, and if applicable, the right bootloader. Some boards have different bootloaders available, and definitely going to want to make note of what serial port it's on. So it's on COM7. We'll need that. So upload the code. Goes through this, shouldn't take too long to upload. There we go. And we're sending serial commands, so I'll come in here and open the serial monitor and give that a test. So we put D write space pin 5, write that high. So if I enter, no error messages, and the light came on. So then D write space pin 5 load. The light went off. So that first little bit checked out. So I'm going to go ahead and finish this code. There's not really any more thought involved in it. It's basically the same thing for the other commands. They should be obvious, the substrings will be different, but otherwise it's basically a copy and paste, and there's no need to put that in the video. So I'm going to finish that up, and I'll be back to run a similar test when, well, I guess we won't really need, I'll run the test because you saw how the test works, and there's nothing new for that, so there's no need to include that in the tutorial. So I'll go ahead and finish that code up and be back when we're ready to call this from PowerShell or something. All right, now we're getting somewhere. So I went ahead and finished the code out. It copied and pasted some slight modifications. All of the logic was in that first example. But to quickly show you what I did, I added a status command. That way we know can make sure the device is ready before we start trying to call functions. Then called the toRead and the other write functions. The only noteworthy things really are, I didn't put it in here, but the analog write has to be to one of the PWM pins. Can't do pulse width modulation just on every pin of the Arduino. There's only a handful of them. So it probably would have been a good idea to put an if statement to check if it's one of those pins. And if it's not one of those pins, send just a 1 or a 0 instead of the PWM of 0 to 255. And the digital read and analog read, I just sent those numbers directly, whatever numbers they read in, get sent directly back to the serial port. So now we can control those pins from anything that has access to the serial communication ports, which is a lot of stuff. Obviously, that's kind of a basic requirement of a programming language to be able to access the communication ports on the machine that's being programmed. So pretty much any language. And it's very, very common for software to have access to the serial communication ports. If you need a deeper explanation on that, we're connected through the USB port. And a lot of software is capable of saving files to a USB port, a flash drive on the USB port or something. So in that case, we could just write a macro in that software that accesses the port and sends these commands down the port. So say from a spreadsheet, just write a macro that sends these commands down the port and imports the data, sensor data from the Arduino straight into the spreadsheet. Wouldn't be any problem at all. For our example here, I'm going to do it from PowerShell, the language for controlling a Windows 10 system. So anything that can be done on Windows 10 can be done from PowerShell. So it seemed a good thing to do in the example. But now we have a way to access the Arduino read and write pins on the Arduino from anything that has access to the serial communication ports. And a lot of software has that, so we could just put it directly in the macro where we wanted it. And you just want to build something up like this. Like I mentioned earlier, it's a lot easier to remember the protocol if you created it yourself, because then it's not really memorization. All the functions are just what you would call them. And just start with something basic like this, and just as you need more functions, add to it and build it up, and before long you'll have serial control over every single thing the Arduino can do. Or in other cases, you might just write a custom one. That way you can use all the built-in libraries and examples and things that are already there, and just add in some control from the serial communication board. It's up on what you do with it, but just a little example. We now have a way to control the pins from anything that has access to the serial communication ports. So let's go over to PowerShell and control it from there. So obviously it could be very, very easy to get incredibly carried away here. Hook up distance sensors and motion sensors, all sorts of things, distance and motion, so that something happens when we just get close to the computer, or any number of maybe a little touchscreen input, a little TFT screen running on the Arduino. Be easy to get carried away. So to try to keep the example simple, I'm just going to use that little benchmark test thing I showed. So a potentiometer, and I just pick some random pins that'll work. So that's, what is that? A4. Then the button on here, tactile momentary switch type button. So when you push it, it sends on, and it's wired up so when I push it, the signal jumps high, and when I let off it, the signal drops low. That's running to pin 2, and an LED running to one of the PWM pins. What I use, pin 5, that has PWM on it. And yeah, so hopefully try to keep this example from getting carried away, but I really did kind of, I even started plugging up what I mentioned a moment ago, a motion and distance sensor, so that when I walk up to the computer, something happens. But to keep the example simple, why don't we just do that on a button? And so that's the circuit that we'll be using. Okay, so here we are over in PowerShell. If you're not familiar with it, basically this is the language to control a Windows 10 machine. Sort of an upgrade on the old Microsoft command prompt stuff. That was wrote back in the 80s when everything had to be abbreviated. And we don't have to abbreviate stuff anymore, so the instructions are spelled out, which kind of makes it nice. I've been using computers since the days of DOS, so I was very familiar with the command prompt stuff and a little hesitant to change myself, but once I started using PowerShell, I was very happy with it. If you're not familiar with it, start small, just create some folders, put some files in them, and just let it build from there. But it's a full scripting language, so you can do all sorts of stuff in it. But this is about controlling the Arduino, so let's go ahead and do that. I tried to embed the video, but it slowed everything down, and there was like a 1.5 second delay between pushing the key and it showing up on the screen, which was really throwing me off. So I'm just going to have to kind of mix videos. After I turn the light on, turn the LED on, I'll do a phone video showing the LED is on or off or something like that. It was just slowing it down way too much. So it's a $sign language. So our variables need to start with a $. which has that nice advantage of we don't have to concatenate strings. We can just throw a variable right in the string, which isn't going to show up in this one. But so I'm going to save this. First thing, we have to open the serial communication. So I'm going to save it to this variable. I'll just call it ARD, short for Arduino. And there's a slight technicality here, but I'm going to go ahead and say it anyway. So if you're familiar with working with Microsoft and Windows stuff, I'm just going to say net32. There's a slight technicality, but basically we need an instance of the same object we would call if we were in, I don't know, VB or C Sharp, anything in working with net32, any of our Microsoft stuff. We're going to create an instance of this object system.io.ports.serialport. And then the arguments we need to send it, well, what COM line is it on? So we're going to send it to COM7. And again, PowerShell is a control thing, so you can get all that information right from PowerShell. You can just ask what's connected to the COM ports and get all the information to figure out which one it is. An easy thing to work into scripts. COM7, then we need the baud rate. I just set that at the basic 9600. The third argument is parity checking. By default, Arduino doesn't use parity checks on the serial communication, so we have none for the parity. And then the last one we need, there's more arguments that can be passed in for more control, but the last one we use in this example is how many bits are in a chunk of communication. Is kind of what this one is. So we're communicating with an Arduino, so we're going to send bytes. So 8 bits at a time. So that just stored that communication into this variable so we can access it easier. And if you like C Sharp or VB, Visual Basic, it's net32. There's a slight technicality doing that here in PowerShell, but that's the same object we would instantiate in C Sharp or Visual Basic. Or VBA if you want to do it from a macro in Excel or something. So, well, obviously now that we have the object for the communication, we need to open our port. And now with the port open, we can just send commands. So Arduino.writeLine, and I guess the first line to write is we're going to write status. Just to check to see if it's ready. Then Arduino.readLine, and we don't need any arguments to read the line. The next line coming back from the serial port just said ready. So it connected and communicated. So let's try writing some of the pins. So we'll write line. We'll call dwrite. Well, it needs to go in as a string. Dwrite pin 5 high. So I'll write that. And the light came on. So let me insert a quick segment of video from the phone showing the light came on. Okay, so here is that last line wrote in PowerShell, and you can see the LED came on. Okay, so now that we know that our communication is working, we turn on lights. Let's do something a little more interesting to finish out the example. Clear all this. So this is what I was talking about spelling things out. So you might remember the abbreviated versions from the older command prompt. Now it's spelled out. If we want to clear things, clear host. The window here is referred to as the host. And we actually spell out the instructions, which in a lot of ways makes them easier to remember. And typing a few extra letters is not difficult. So we need something to do. So I'm going to create a function. Our notation for that in PowerShell is the keyword function, the name we're going to refer to it by, and in parentheses I'll pass in something, pass in some result that we get from the serial port. And then in curly braces, say what the function is going to do. So this one is just going to check if, well, the result is going to be passed in whether the button is being pressed or not. So if it's a 0, it's not being pressed, and if it's a 1, it is being pressed. So if result is greater than 0, that's how we do the greater, less than, GT, LT. So just an if statement, and curly brace for the blocks is just some PowerShell notation. And we need something to do. So what's something good we can do real quick? I have an idea. So if the button is being pressed, or my original idea that I omitted using distance sensors and motion sensors, if somebody walks up to the computer, it kind of trigger in the same way. Let's start a process. And what process are we going to start? File path. Let's go to chrome.exe. And we don't need the entire file path because if it's in the start menu, PowerShell knows about it. So we can just use the name. But if it's not in the start menu, you have to do the whole file path. And let's not just open Chrome, let's go somewhere. So for an argument list, let's go to YouTube, www.youtube.com, and then we'll check the results of a search query for Arduino. That seems like a good thing to do for this example. Let me check the first typos real quick. HTTPS : / Okay, yeah, that looks good. I was talking and typing at the same time, and that greatly increases the chances of making a typo. We'll close out our curly braces. And so now we need to see if the button's being pressed or not. So that variable, the arduino.writeLine, and let's write the line dread whatever's on pin 2. And now, before I push enter, I'm going to go hold the button down. So I know it's not on the video, but I am holding the button down right now. So now push enter. And so it sent that command and check the state of the button, which Arduino quickly checked the state of the button and sent that back to the serial port. So sitting on the serial port right now is the result of that instruction. So we can call that function. So let's call doStuff and pass the parameter, which in PowerShell things are space delimited. So we're going to do stuff, and the argument we're going to pass in is r.readLine. We're going to pass in the next thing on the serial port. So we run that. Opens Chrome, goes to Google, goes to YouTube, searches for Arduino, and pulls up these videos. So there's probably some good suggestions here on neat little controllers we can use to do things, right? Have the Windows machine do something when the temperature, based on the temperature it is. Or there's really no limit there. But hopefully that stuff kind of made sense, at least the general logic there of we just set up the Arduino to read and write the pins based off instructions coming from the serial port, and then we just sent the instructions down the serial port from the laptop, and now we can control stuff on the laptop with sensors connected to the Arduino. So I just wanted to share that. That's kind of what I do instead of using the Raspberry Pi. What started this is I made a quick video talking about why I never use the Raspberry Pi, because If I need a system, I just use my regular system, which is typically a laptop, or run the serial port through Bluetooth to a tablet or phone. And then I don't have to go through all the trouble of hooking things up. I don't have to hook up a monitor and dig out cables and hook up a keyboard, probably find batteries for a keyboard and a mouse, and don't have to go through all the trouble of hooking up a system like I would with that Raspberry Pi. And just every once in a while I pull one out because I think, oh, it's been a long time since I've read that. If I need a whole system, I just set up an Arduino and use those as GPIO pins for my laptop or tablet, usually running through Bluetooth. But hopefully y'all can carry that from there and make some really neat stuff. Feel free to, or please put in the comments some of the things you came up with to control your laptop from an Arduino. Thank you. Have a great day.